Hi, my name is Atharvsheterobotics. I am applying for software engineer for collaborative AI robotics position at Ai Robotics. Uh, I am trying to showcase my project in this video. After I will show it on the screen, which will be displayed here on this video, and I will be explaining my smart autonomous luggage carrier robot in it. It contains both AI and hardware implementation. So my approach is to implement the AI in robotics and also in this electronics parts. It will be collaborating both the things and making useful product from these things. I am using here computer vision models like for detecting the human, means using a deep learning model for detecting a human, and using hardware stuff such as ESP32 and Arduino and webcam for detecting the human and running the robot. Okay, so I have used here Triamner robot, which is a stable and holonomic system. Uh, it uses omni-drive wheels for rotation for its movement. So omni-drive wheels are usually stable. So we have designed here the Triamner robot, Triamni system, which uses three omni-drive omni wheels. So these are the omni wheels which we have used here. We have used Triomni so that it will be using holonomic drive system. Here then we will be coming to the object detection part. This is the main code which we have seen here. So I will be explaining this code. As you can see here, the object detection has started. It is sending the values to our ESP32, which we have used here. We have shifted our origin from the 0, 0 to this 300, we have calculated manually. We have this 320, 480. These are the x and y values which we have calculated manually and shifted our origin from this point to this 320, 420, 320, minus 420, 480, I think. Okay, so we will be calculating the x and y values related to it. Further, I will be showing you how the detection works. So this is the code which will be displayed in the screen after, which you can access afterwards. So basically I have used here ESP32 module for sending the coordinates wirelessly from this Python program to the Arduino. I will be displaying you the part here. So this is the basic simple ESP32 socket library for connecting the ESP32 and our Python program. So it connects Python and ESP32 using this IP address of using wireless Wi-Fi module, which is inbuilt in ESP32. Then we have used here function for sending the values from Python program to the ESP32. Then we have used here media pipe library of post detection, which you can see it is publicly available on the media pipe library. It is of Google, you can see. Then yeah, so it is using deep learning model. I have only used the deep learning model which is publicly available. So it is having this, means I have used here the camera model which is inbuilt in the computer, but we will be getting the values from this IP address, which is using a webcam. I have used of mobile's camera, which will be showing you afterwards. So here we have used the capd show method. It is fastest method to open a like this device which we will be using here. So we have used here, these are the lines which we have created. This line you can see here, these are the two lines which we have created here for shifting the origin. Then we are getting the landmark coordinates from this part. So it is giving the landmark coordinates in an array. So it will be storing the array in the variables. So these variables are calculating the midpoint, such as here you can see, as a human is detected, there is a bounding box created here. So this is the x1, x2, x1, y1 point, and the bottommost corner point, which is x2, y2, and we are calculating the center coordinate of these between a bounding box. So consider here it is as a square box, and this point as our x1, y1, and this point is x2, y2, and we are calculating the center point by using this midpoint theorem. We are calculating here x1 plus y1, x1 plus x2 by 2, and y1 plus y2 by 2. Then we are calculating the error point, how much distance we have to calculate. So here you can see this is calculating the center point, which is somewhere downside, and this point. So distance is between x point, this is calculating here, and y point also it will be calculating. So it will be calculating the error here, then sending the values of error, which you can see here. As it is mentioned here, I have shown here that the x1 and y1 coordinates are calculated likewise here. It will be different when the person will be far apart, so that the coordinates will be given easily. We have also the arrangement such that the robot will be calculating its, means it is a matter of the place where the camera is placed. So here calculating the rectangles and drawing the values here. Other things are basic, so I will be not showing other things. So yeah, after this we will be closing this program. As you can see here, this is a tram new robot, which is a holonomic in system. I will be showing you how I have calculated the motion of, means using mathematics. I have used vectors for calculating the equations for the robot, which will be I will showing here this. So as you can see, the wheels are arranged in such a way that it is 120 degree apart from each wheel. So this is the wheel here, and this is apart 120 degrees from the other wheel. This is wheel 1, this is wheel 2, this is wheel 3. So we need 3 equations for calculating the equation for sending the values here. So we have calculated here using this thing. So first we will be calculating for motor 1 value. So it will be p sine theta 90 minus theta. Okay, so this value which we have calculated here, we are getting the x and y coordinates, which will be having some position. These are the x and y coordinates we are getting from the bounding box's center coordinate. So we will be calculating the magnitude, which will be calculated using under root of x square plus y square. So it will be giving us the coordinate, means this is the magnitude value which we will be using here as a magnitude, then sine and 90 minus theta. So as when the robot will be moving towards, means we will be having the coordinate systems here. Okay, so the theta, we need the theta value, which will be calculated using tan inverse y by x value. So this tan inverse y by x, this x and y coordinates will give us this value, theta value, which we will be putting here. So after getting this p and theta, we will be getting this m1 equation. For m2 equation, we can see here that it is 120 degree plus 90 degree, so it will be 210 degree. So m2 equation will be p sin theta 210 degree minus theta. Same as m3 here, we will be calculating p sin theta 330 minus theta. So we have calculated these things for m1, m2 and m3 motors. So my project will be, I will be showing you this thing. As we have connected Arduino, this Arduino will be connected to a motor driver. This motor driver will be sending the values, analog values, to the motors, which will be giving analog values. These motor values will be calculated using these equations here. We will be having constraint of 255 value, means minus 255 to 255 value, depends on each motor drivers. As I have used here Citron motor driver, which will be having minus 255 to 255 degree. If we use saber tooth, we will be having 0 to 128 values constraint, which will be I will showing you. So by this motor values will be given from these values. As we have seen here, the saber tooth values will be 0 to 128. Okay, so after this I will be having this ESP32 value, ESP32, which will be connected to this Arduino using, this will be having power supply of 5 volts, and also this will be having a 12 volt supply. We will be both, okay, 12 volts, we will be delivering both as a 12 volts using a power bank. So this ESP32 is wirelessly data transfer using, this is wireless data transferring using Python Wi-Fi module in the ESP32, and this Wi-Fi module interacts with the Python program to connect the OpenCV and media pipe to this Wi-Fi, to this ESP32 module. So these are the steps we will be creating here for the moment. So after the detection, these x and y coordinates which will be shared here, so these are calculated using this magnitude and angle, and this will be shared here, and these values will be shown to our motors here. So you can see here we have used Arduino IDE for connecting the ESP32 and Arduino module. This is taking the serial module, means communicating using serial communication. This is the baud rate, which is 9600. It is calculated, which is inbuilt. So it is taking the serial input, means in string form, and it is converting into the value, which is the int value. Here the string value is converted into value, and this is the constraint which we are putting it, which is 0 to 255 values. So here analog values we are converting into analog values. So we will be using this library for in communication between ESP32 and Arduino. As you can see here, this is the Arduino's code, which is I am using H-bridge motor driver L298. So it is their format for giving the values. I am using 9, 10, 11 pins for the analog values, and this motor 1, 2, 3, 3 and 4, pin motor 2, 5 and 6, motor 3, 7 and 2. These are the values for pin numbers. So we are using the serial library for receiving the commands string into integer format. Then we are calculating the M1, M2 values, M1, M2 and M3 values here, and putting a constraint of this. The equation, as you can see here, this is different from these equations because I am just giving the values for moving it forward. So it will be moving always forward from this part. So wait, I will be showing values here of x and y using this coordinate system. The x and y values are changed when I move from one place to another. Also it is tracking the poles where of mine, and also changing this. You can see here the green dot, that is the center coordinate, center point of this human detected bounding box. It tries to minimize this error using this, calculating this when the center point will be around the certain range which we have around these points. So it will be having the motor values to 0. So the motor will be stopped until it will be trying to reach the point of the center point, which you can see here. As you can see here, I will be running the program. This is only software part which will be displayed here. This Python program, which I am using IPCam. I am using this phone's camera for detection part, such as webcam. It is replacing the webcam. So as you can see, the phone has started. The webcam has started. Now I will be placing it at a certain point, level of some. Okay. So this will be the height of our robot. Here you can see, as the robot is detected, human is detected here. The center coordinate also detected, and the values are sent accordingly to the ESP32. As you can see here, as I move closer to it, center point also changes. Sometimes it gives error for detection. Okay, and we will be calculating only xpid for it, means we will be only considering the values for the x coordinates which we are trying to get. Means when I came closer to the robot, it will be at a certain point, okay, at a certain distance. Means it is not calibrated yet, but at a certain distance it will be calculated. And as far as I am on the x near to origin, nearer to the x parts of the origin, I will be having the values of motor to be sent. Means coordinates will be not that much efficient for the ESP32 to read, but as I move away from the x part, the motor values will be sent accordingly. And when I will coming closer to the x part, means origin part, then the values will be sent fewer. Same as for negative x part. So this I am using here for detection, and after that I will be showing robot's code. Okay, so this is serial library. We are converting the string values to integer to read. We are sending the string values from the ESP32 to the Arduino here. The ESP32 sends the value in string format, and the values are converted into data type, which is int format, and the xy values are here. As the motor we have discussed, we are using only x part of the coordinate systems for calculation. Means after detection we are only using the x parts, and we will be neglecting y parts for some of the calculations. Means here we will be tending our robot to follow only this. We will be trying to make our detection only in this part, and for only x parts we will not be calculating for y parts, as it is for distance coordinates. We will be only calculating for this x part, so that the robot will be detecting its surrounding surfaces, and for distance, measuring the distance, how far it is, we are using an ultrasonic sensor for detection, and the ultrasonic values are read. The values are taken from the ultrasonic sensor and given to this values afterwards. I will be showing you that code also after some time. Here the values are calculated, and we have put here constraints. We are using means this is the threshold value at which the robot motor starts. We calculated which threshold values are able to start the motor. Means at 0 value the robot doesn't start, means the motor doesn't start, so we used from these values, and we are sending these values to motor functions. This is motor function, it is taking analog values, and the edge bridge syntax for driving the motor, same as for M2 and same as for M3. As we have discussed, we are using only the KP part, means in proportional part we are neglecting this KP and KID part. The gains are always calculated using tuning method. We are not calculated because we have achieved our target. So after this, the other part is, as I mentioned, we are calculating only the XPID values here. The YPID values are associated with the distance, means the robot is here and the person is here. We will be only detecting the part which is for robot to move in left or right. We will not be. As you can see here, we are having this PID equation, which is full equation: P proportional integral d derivative gain derivative and this integral I. So we will be using only error term of proportional term, which is having this. We are tuning this afterwards. We have not tuned it yet. We are tuning using Nichols-Signal method, which is trial and error method for detection of this. After this is the error which we are getting from the camera feed. So as we are talking about the camera feed, we are having this frame, we are having this origin, and we are calculating the distance between them. We are using only XPID values. XPID means only this for moving left and right of the robot. We are not using this Y part. Okay, so we will be using only X part to read this X derivative, X part of the gain, X errors, and we try to minimize this. Means if the person center point is somewhere here, we will try to bring it to the X part, and we will be moving towards it using the VL53, which is another distance sensor. This is a distance sensor using lidar sending the light coordinates to detect the distance between them. As you can see here, we are having this robot which is having the camera detection, and we are using this distance sensor for measuring the distance between the person and the object, our person and our robot, and we will be moving with left and right using these computer vision models. What's your name? Hi.